Presten mucha atención a esta alarmante cifra, 600.
La población de chigüiros, zorros y varillas en los llanos ocasionarios
Vamos a Colombia, ahora sufre una sequía extraordinaria que podría obligar también a medidas extraordinarias por parte de las autoridades. La mayoría de los departamentos del país son
You may have heard that we are running out of water. Let's investigate about it. Where's water?
We all needed water, but only 2.5% of water that is on the earth is fresh water. Globally, the domestic use of fresh water represents only 8% of consumption, comparing with the 70% that accounts for agriculture and 22% that corresponds for industries. The construction industry is responsible for 16% of world water consumption, while 9%, which corresponds for the industrial sector, is used for concrete production. Concrete is everywhere, and its demands continues increasing rapidly. It is estimated that concrete production will intensify up to 80% and 90% in countries like India and Brazil by 2050. Consequently, if current practices of preparation continue, more and more freshwater supplies, which are critical for the survival of human civilization, will be depleted.
So, what can be done about it? Would it be possible to use fresh water in the concrete industry?
Seawater mixed concrete could reduce the use of fresh water. However, seawater has an average salinity of 3.5%, from which 78% is sodium chloride, causing the corrosion of steel rebars. Therefore, its usage is currently prohibited by construction committees.
Are there any other alternatives to reinforced concrete?
For sure! The importance of corrosion justifies continuous searching for new technologies that could be used in the concrete industry. For that reason, glass fiber reinforced polymer bars become a great option, since they don't rust and are an excellent alternative for buildings with such strong mechanisms against corrosive agents. Glass fiber reinforced polymer bars do not react to salts, chemical products, or the alkaline present in the concrete. Fiberglass rebar is a stronger and lighter alternative to conventional steel rebar. It is a quarter weight of steel, superior in tensile strength, not magnetic, and non-conductive rebar that has a cycle of more than 100 years. Although corrosion-resistant reinforcement has a relative higher initial cost, fiber reinforced polymer using conventional concrete structure reduce maintenance. On the sustainability aspect, mixing concrete with seawater will lead to a reduction up to 12% in its water footprint. This is due to an innovative mix design that incorporates fine aggregates, cement, SCM, mixtures, seawater instead of freshwater, and glass fiber rebars as reinforcement for concrete.
Consequently, our proposal is to conduct tests to investigate and assess the incorporation of seawater in replacement of freshwater for the elaboration of reinforced concrete with glass fiber reinforced polymer rebars, which is going to contribute in the use of sustainable concrete in reinforced concrete structures. We've considered that a research proposal will need the approval of committees ACI 201 about concrete durability and Committee ACI 211 about proportionate concrete mixtures, which could be the best candidates to fit in this proposal. We must take into account the following considerations. The workability and setting time of concrete are reduced by the effect of seawater, for which the addition of admixtures in accordance with the ASTM C494 standard should be considered. The compressive strength of concrete mixed with seawater is slightly lower, 10%, compared to conventional concrete, freshwater. So, complementary alternatives should be investigated to avoid this effect. With respect to the design and construction of a structural concrete reinforced with fiberglass reinforced polymer bars, all the considerations established by the ACI 440 Committee on Fiber Reinforced Polymer Reinforcement must be taken into account. Fiberglass rebar is ideal for infrastructure projects such as water treatment plants and retaining walls. Over time, and often due to the conditions in which they operate, many industries experience problems with the degradation of their reinforced concrete infrastructure. runways, airports. Runways must be built with a long-term vision. These runways must be built with fiberglass reinforcing material so that they can withstand the impact of more than 500,000 pounds on the main runways. Seawalls. Marine structures such as dikes, breakwaters, artificial reefs, floating sea docks that provide protection against flooding and erosion, as is the case of the LA dock located in Miami, Florida. Precast. By using fiberglass rebar in precast products, it will extend the service life of precast concrete to 100 years or more. Mitigation channel. In Saudi Arabia, the construction of the largest reinforced concrete structures with fiberglass reinforced polymer bars was recently completed. The 21-kilometer-long liner is the largest concrete structure in the world. Glass fiber reinforced rebar is an ecological product that helps to reach certain LEED credits in both Canada and the United States. It's the most effective solution to build sustainable concrete structures. This is how the use of seawater with fiberglass reinforced polymer rebars stands as a great alternative, bringing with it the efficient use of water resources through responsible production and consumption to ensure sustainability and water supply, promoting sustainable cities and communities. A valid possibility for freshwater preservation in the concrete industry is represented by the use of seawater. The current objectives that are being worked include the projection of a new generation of specifications for construction and design that will perform the inclusion of American National Standards Institute. The relation between sustainable concrete and GFRP reinforcement would amplify the availability and sustainability of built elements in aggressive environmental conditions without altering its service life and durability.